This is the video for our Algebra 2 project. It is on exponents and all their properties, and it is by me, Claire Ebersbach, and of course my partner Viana, without whom I could not have grasped this concept. Now, there's really quite a lot that you can do with exponents and their properties. You can go with zero exponents, fractional exponents, you convert them to radical form, you convert them to back to radical form. There's a whole lot of confusing stuff you can get into, but really the first thing we need to cover, I think, is the four most important properties or rules involving exponents. So the first property we'll be talking about is called the product of powers and can be represented by the equation x to the a power times x to the b power equals a plus b. And so this is the rule that when you multiply two of the same bases, in this case represented by the variable x, but with different exponents, you multiply the bases because they're the same, but you add the exponents. So you wouldn't multiply them like you might think you would. You instead just add them and use that sum in your final answer. So a nice example of this really product of powers is x to the third times x to the second power. So it really helps to write it out like this, like x times x times x plus x times x. And when you really rope that all together, you get x times x times x times x times x, or x to the fifth power. The next rule we will be discussing is called the power of a product. And this is represented by the rule ab times the exponent m equals ambm. So this is the rule when you are multiplying two or more variables or constants. I know in the rule it's represented by variables, but they can also be numbers, which is a special case, by an exponent, which in this case is represented by the m. You distribute both of the exponents, or you multiply the exponent by both terms. So you distribute it to both of the terms and you end up with a result where both of the terms have exponents. So for this example, we'll be providing sort of more like a lengthy example because there's a lot more stuff that you can do with this rule. So for the first one, it's normal just with variables like in the rule. So let's say you have an exponent of 4, you just distribute that exponent of 4 to both of the variables. But in the second example, when there's a constant or a number, in this case 8, and it still has that exponent of 4, you just multiply 4 by 8 to get 32. And then the b remains normal, just having that 4 exponent. So the next rule that we'll be learning is called the quotient of powers. And this is represented by the rule a to the m divided by a to the n equals a m minus n, which equals 1 over a n minus m. So this is the rule that when you're dividing numbers with the same base but different exponents, you divide the base, but you subtract the exponents. So when you have the same base as represented by the variable a, but different exponents as represented by m and n, you divide a as normal, but you subtract m and n. And something unusual about this rule, or at least the way I learned it, is that your final answer must have no negative exponents as represented in the 1 over a n minus m. So a good example for this problem would be 10 to the 6th power over 5 to the 2nd power. And so, of course, 10 divided by 5, as we all learned in kindergarten, is 2. But 6 minus 2 is 3, so our final answer would be 2 to the 3rd. But wait, we have to do the negative exponent thing. Since there are already no negative exponents in our problem, all we have to do is put a 1 over it, so our final answer would be 1 over 2 to the 3rd. The last rule we'll be discussing is called the power of a power, and this can be represented by the rule a to the m power times n is a m times n. So this is the rule that when you're multiplying a term that already has an exponent by another exponent that's usually represented outside the parentheses, instead of applying this exponent to both the term and its other exponent, you simply multiply the exponents as opposed to multiplying the exponent and the term. So a good example for this rule is a to the 4th power times the exponent 8. So you'd simply multiply the exponents 4 and 8 to get a to the 32nd power. So, in summary, exponents is a very complex and confusing subject, and like I said, there's a lot of stuff that we didn't get into in the video that can be very complex and confusing at times. But I think the most important thing to remember throughout this video is the 4 rules that we covered, namely the product of powers, the power of a product, the quotient of powers, and the power of a power. I think these are really the foundation for the properties of exponents, and every complex thing that you use can be traced back to them. So this was the video on the properties of exponents by Claire and Viana. I hope you enjoyed it. I know that I certainly learned some more from about the properties of exponents. I had to look some things up to make this video, and as a result, I think I've come to a better understanding of the 4 rules, and how they should be applied in mathematics. And anyway, thanks for watching.